Well, in this presentation, I'll talk about what is available in Java 9, but I'll split it into three different parts. I'll talk about improvements and changes, things you could already do, but you can do it a lot better than before. Additions, things you couldn't do before, but you could actually do now. And I really wanted to call this as descriptions, but I want to put a positive spin on it. We'll call it as advances. If time permits, I'll talk a little bit about modules towards the very end. Let's talk about some improvements and changes along the way. Well, the very first thing I want to talk about is changes to the interfaces. So let's talk about interfaces just a little bit before we go any further. Let's go to days of Java 7 or before. What was really interfaces? If you really think about it, an interface, let's say util, for example, and I'm going to create a method here called, let's call it as get number of processors, and this is a little interface we are creating right here. Now in this case, we are just looking for the compiler being happy, so I'm going to just run this code. You can see the compiler is quite happy with what we just wrote. But of course, we know one thing though. If I try to implement an interface within this, for example, if I were to say return 4, you know the compiler would be very unhappy with me, right? And the reason, of course, is interfaces cannot have implementations. So in the past, in Java, what were interfaces? Interfaces were simply a bunch of stuff that would tell potentially what it can do, but it never does anything. Kind of like my boss. And as a result, nothing useful comes out of it, right? So the point really is that that changed very dramatically in Java 8. In Java 8, of course, interfaces can have implementations. So if I were to say return 4 right here, but we can mark it as a default method within the interface. Similarly, interfaces can have static methods also. So in this case, if I were to define a static method, again, let's just say return 4 for a minute, that was permissible also in Java 8. But that begs the question, if interfaces can have implementation, what's the difference between interfaces and abstract-based classes? Well, interfaces cannot have mutable fields, abstract classes can have. Well, having said that though, if we can have implementations within interfaces then, well, what if there is something common between multiple methods we create within interfaces? Well, obviously that will lead to duplication of code, and we know that duplicating code is really a bad programming practice. So what do we typically do in classes when there are things that are common between methods? We group them into, or move them, or refactor them into a separate method. We call them as helper methods, but typically we would make those methods as private methods. Well, that's now something available in Java 9. So in Java 9, you can actually define what are called private methods as well. So in this case, let's say we'll get, say, something, for example, and whatever that method, I want to reuse it. And I'm going to simply return a 0, for example, in this particular case, and you can see that it's pretty happy with the private method. Notice you don't put the word default. Well, private methods are useful to be called within default methods. For example, I can call that method from within here. Similarly, we can also create a static private method as well. So we can say, in this case, private static. And of course, while you can't put the default keyword with private, you can put the static keyword. So get something 2, for example, here, and then I can, of course, let's say return just a value of 0 again, and you can see that that's pretty permissible. So you can have private methods within interfaces, and that is something that Java 9 permits. Again, I would say don't overuse it. It's not the intention that you start writing a lot of private methods within interfaces. You want to be really, use it sparingly. Well, let's talk about try with resources. But before we talk about it, let me tell you about a theory that I've come to realize in my life. I've been programming for about 30 plus years now, and over the 30 years, what I've learned is the following. We solve one set of problems only to create a new set of problems. And this is being simply the model of life in general. So when we finish solving one problem, we always look back and say, gosh, what did I do now, and what did I just create at this moment? Well, it turns out Java has done its part for this problem. Let's say we have a class called resource for a minute. And in this case, I'm going to create a constructor for the resource. Let's simply say over here, let's say created. So if I say created right here, that's showing the constructor call into it. Let's say we have a method op1. And all I'm going to do simply is just print out op1, and then we'll simply return this for a minute. Now, of course, if this code is using memory, we don't have to worry about memory because Java has automatic garbage collection. But we know that Java garbage collection is automatic, but it's not instantaneous. There's no guarantee when the garbage collection will actually happen. Well, then if we have external resources, maybe an open file, maybe a database connection, or a request to a remote server, how do we really manage those external resources? Well, there's no really good answer at the time when Java was created, so they decided, why not write a function called finalize, and in the finalize method, maybe we can do the cleanup of external resources. So we will, if there's an external resource, we'll clean it up in the finalize method. Well, unfortunately though, finalize is called when the garbage collector kicks in. But we know that the garbage collector, there's no guarantee when the garbage collector will kick in. As a result, this external resource may be held for a long time, and we don't even know how long it's going to be held, and that's going to be a problem. Well, thankfully in Java 9, finally, finalize has been deprecated. So if you're using finalize in your code, you're going to get a warning moving forward, which is a really good thing. But let's continue a little further with this. We create a resource object equal to new resource. And then, of course, I'm going to call resource.op1 right here. Notice that we got a warning, but certainly it did not actually call the method for us. In this particular case, it's not going to really perform the cleanup operation for us. Now, why is it not going to perform the cleanup? And the reason is no guarantee of garbage collector being called. So to handle this, what Java 7 did is Java 7 introduced a fairly nice feature, which is called ARM, Automatic Resource Management, or also called as try with resource. Well, the try with resource typically says that if you want to clean up this object more deterministically for external resources, then you can go ahead and place this within a try. But notice how we are creating this resource right here in the call to the try. For this to work, of course, you're going to provide a close method rather than providing the finalize method. And then you're also going to implement right here, and in this case, you're going to implement the auto-closable interface. Well, with this approach, you're going to see that the object is garbage collected for you. In other words, the object's memory is external resources being cleaned up when the object leaves this particular scope right here. And this object, of course, is no longer available once you leave this. Well, that's great. We solved one set of problem, but unfortunately, we ended up creating a new set of problem. And that is, if you watch this code really carefully, let's do a little refactoring. Let's call a use method right here, and let's move this to a use method for a minute. So if I were to create a use method right here and move this code inside of the use and call the use method, well, we can see that's working certainly. However, notice what we did right here within the use method. We created this object using the new keyword. I would say new is the ugliest keyword in Java. And the reason is, what does new really mean? New means type coupling. New means I want that particular class and nothing else. And we know that type coupling is really not a good idea. In fact, an entire slew of design patterns called the creational patterns exist just so we don't use new in the code. In other words, what do we normally do to avoid this problem? Well, there are two things we normally need here. One is we normally use dependency injection. So we want to be able to bring in a dependency which could be injected with other tools. And the second is, if a code depends on an external class, if the testing becomes really hard, we want to typically use a stub or a mock to really replace that object. Well, both of those things are really hard right now because of the restriction that the try places in this case. Well, good news, that restriction now has been removed in Java 9. So what you can do now in Java 9 is you can bring that resource from the outside. So you can see right here, I'm going to say resource, and then of course within here, I'm going to simply use the resource that's being provided to us. This code will not compile in Java 8, but this will compile in Java 9 moving forward. So in Java 9, you have ability to bring an external object, but then wrap it into the try with resources. Well, the good news is now, as you can see, the cleanup of the object automatically happens when you leave the line of code, line 20. Now, I said that you solve one set of problems only to introduce a new set of problems. Well, great, we solved one problem, but what's the problem we have now created? Well, the problem right now is that object is still available for your use after you leave the try block. Well, remember, you have cleaned up the external resources at this point. So you should ask yourself the question, is it okay to access the object after the external resources have been cleaned up? If it is not, you need to really error-proof this so that it doesn't lead to other consequences in the code. So that is something you have to be very careful about. So this is the restriction that's being removed. Well, one small detail here is, when you use the try, this has to be finally object, or our resource has to be, the reference has to be a final resource, reference. Well, it's got to be final, so you could mark it as final like this. But we know that if you don't mark it final, we know that it's effectively final as well. But of course, if you were to change a resource, let's say here, even setting the resource back to resource, that gives you an error because the resource that you use in this particular concept must be a final variable, and because you're modifying it, it's no longer effectively final, and so that's not allowed. So that's basically the changes to the Java language to provide a little bit more flexibility when it comes to the try with resources. Well, if you were been using Java 8, you probably got this already. Suppose you are using a variable which is a single underscore, something like this. Now, if I were to say okay right here, if this were Java 8, you would have gotten a warning when you compile your code. Well, the reason they use this warning is languages like Scala and Kotlin typically are using various different symbols to represent variables that don't have much significance. Especially one variable, underscore. If you're looking at languages like Scala, the last time I checked, underscore had 7 different meanings within Scala. Well, underscore is special. There are only 2 kinds of programmers who use Scala: those who like underscore and those who hate underscore. So the jury is still out on this. We're not sure if this is a good idea or bad idea, but in the case of Scala, if you're using a pattern matching, suppose you have a variable input, and you could say match, for example, right here, and then within this you could say case, maybe a value of 7, and you can do something when the value is 7. But what if you don't care what the value really is? Well, you use an underscore. Why underscore? Because underscore is the international symbol for I don't care. So essentially, if you don't care about something, you just use an underscore. And as a result, this underscore has a special meaning in programming, and so Java is considering using that international symbol for I don't care, which is underscore. So they are thinking maybe we should use underscore when we do introduce pattern matching. Well, the jury is still out, but they want to grab that, they want to put dibs on that underscore. So they have actually created a warning in Java 8, but as of Java 9, notice it's actually an error. So you cannot use underscore anymore as a variable name in your code. But of course, this is only for a single underscore. I'm not recommending you do this part. If you had a max with the underscore in before it, it doesn't complain. So the moral of the story is quit using underscores. Well, I said this to a developer a few months ago, and he was very quick to respond. He said, no worries, I won't use underscore anymore. I'll just use 2 of them, he said. Don't go there. That's not a good idea. Can you imagine coming to work one day and seeing variables with various length of underscore? It's not going to be very inviting. So absolutely don't encourage such practices. So don't use underscores. Well, the next thing I want to talk about here is something that has been added to streams, and I'm really happy for this because this is really a good addition to the language. To understand this, let's take a look at an example right here. I've got a bunch of values. Let's say we have 11, 21, and maybe a 31, 14, and 51, just a bunch of values, if you will. So given these different values that we have with us, I'm going to write numbers.stream. And I say dot filter, given an element, I'm going to say element less than, let's say 50, and then I'm going to do a for each system.out over here, and then I'm going to say println. Now in this case, I'm just using a filter, if you notice, and the filter is getting us all the elements which are less than 50. Now given the collection that we have on our hand, notice that our collection contains all those values, and we got everything that's less than 50. Let's talk about filter just for a minute. It takes a predicate, of course. Well, but after taking the predicate, it is like a switch that can be turned on and off. So this is kind of like a switch. Per element it will turn on and turn off. It lets go of 11, 21, 31, 14. It blocks 51, but it lets go of 16 and 17 and 18, but it blocks 91 and 110 based on the value returned by the predicate. So we understood what a filter is doing. On the other hand, instead of filter, if we were to use a limit function, in this case I say limit 3, notice it only lets first 3 values go through. This is available in Java 8. All I'm showing you here right now is part of Java 8 already. So limit allows you to let that many number of values go through. But if you look at limit itself, it takes a number, if you will. On the other hand, limit is like a door, and this is that is open, but will close, forever, after the limit is reached. So this is basically the limit method that's been provided. Well, but notice the little discrepancy here. Limit is like a door that is open, but when a certain condition is met, the door will close forever and nothing will ever go through it. So that is why in this case the door closed after 3 values, never to open. But rather than using a limit in Java 8, you can also use a skip. And the skip method says, I'm going to skip 7 values. Notice it left away 7 values and gave us only 3 values after that, or all the values after 7. So how does skip really work? The skip method, on the other hand, takes a number as well. But skip is like a door again, but this door that is closed but will open eventually forever. So in other words, it's the opposite of what limit is doing. But again, notice a discrepancy here. While filter takes a predicate, limit and skip only take a number. How sad. Why not pass a predicate? For example, I could say, I want to take the first 7 people in this room. Or I could say, I want to take everyone in this room until I find a person with a blue shirt. Well, the second one is based on a condition rather than the count. It could be 7, it could be 20, it could be everybody who knows, but I'm going to keep looking for a person with a blue shirt. So the point really is, why not be able to limit based on a predicate, a particular value? Well, here comes some fun facts. If you look at languages like Haskell, which purport really nice functional style of programming, to what Java provides, let's compare for a second. Haskell has a take and Haskell has a drop. Now when Java was created, the functional style in Java was created, they could have called it take. But it's as if language authors get together and say, tell me what name you use, I'll make sure I don't use it. So they are intentionally kind of inconsistent in a way, isn't it? So rather than calling it as a take, they called it limit. And rather than calling it as a drop, they called it a skip. You know what? That's okay, we can get used to it, right? But here comes the charm. Haskell also has a take while, where the take while takes a predicate, while take takes a number. Similarly, they have a drop while. Now the question is, what should Java call this? Well, logically speaking, you may say, gosh, because they called it limit, you may be expecting this to be limit while. But heck no, they wanted to call it as a take while, right? So they want to be consistently inconsistent, which is a pretty good quality to have in my opinion, right? So similarly, this one is called as drop while as well instead of a skip while. So what you can do in here is, I'm going to go back to this code and say, rather than the skip, I'm going to say a take while, and given an element is less than 50, real quick, let's just compare this with the filter. When I run this, notice I got 17 and 18 as well. On the other hand, when I use the take while alone, I'm getting only the values until the first element, which is greater than 50 or equal to 50 is seen, and then the door closes at that point. Similarly, you could also say skip while in here, and then you could say given an element is less than 50, well, until you see drop while isn't it? So until you see this particular value, notice it stops everything, and then it hits that value and the door opens. So that's absolutely a beautiful addition. Here's something I want you to think about for a minute. You take this with a grain of salt, but take while is kind of like the break statement. Not entirely true, but it comes close to it. Similarly, drop while is kind of like a continue. Again, not entirely true, but kind of like that. So anytime you had a need for a break or a continue in your code, think about take while and drop while. This can be really powerful to use. Like I said, this is extremely valuable because I've actually had people complain that they're not able to do really good things with stream because of the lack of these methods. I'm truly happy that they've added these methods finally to the JDK. Well, talking about it, let's really quickly talk about something else as well while here. Let's say you are working on Java 8 and you're really convinced about functional style of programming, and you're telling everyone in your company, let's use functional style. And you're trying to convince one programmer, the one I'm talking about, who loves imperative style, refuses to code in functional style. So you went to this programmer and said, look over here, if you have this loop like this one, here's the good news, you can write this in a beautiful functional style, and the way you can write this is like so, and you show them how to do it. Into stream.range, and then 0 to 5, and then you say .for each, system.out, and then you say println. And then you show them, isn't that beautiful, how you can actually use this functional style to program the range of looping that you show them. Now the programmer who is not happy with functional style, who wants to use imperative style, comes to you and says, oh yeah, how do you do that? And you can quickly answer, oh, that includes up to the value 5, isn't it? And you say range closed, and then you show them how to do that in the functional style. But this person is so adamant, then they come to you and say, oh really, how do you do I equal to I plus 2? The right response in Java 8 at this point is you win, and you quietly walk away. Because if you try to do this in Java 8, it will be really embarrassing. Because when you're done with it, they will post this and make fun of you. Don't want to go there. Well, thankfully, Java 9 fixes this problem. So in Java 9, how does this work? But before I answer that question, notice the output over here. Let's make this 15, if you will. Notice it goes from 0 through 14, but 0 to 4, and so on. But before we answer the question, let's just take this for 1 second, if you will. If you just stay with this for a minute, remember there are 4 powerful, popular functional interfaces in Java 8. And those are supplier, consumer, predicate, and function. Notably, predicate and function, predicate takes a value and returns a boolean, function takes a value and returns another value for mapping. Well, if you look at this now, the for looks like this is a seed value. What in the world does this look like? Well, that takes an input and returns a boolean, so that becomes a predicate, isn't it? And the third thing, notice, takes a value I and returns another value, so that looks like a function. And that is the beauty, it is extremely intuitive. So I'm going to go to into stream right now, and I'm going to call a new method called iterate. And the new method iterate starts with a 0, and the predicate I'm going to provide is given a value I is less than or equal to 15, and the function is I equal to, given a value of I, return I plus 2. So notice how we were able to translate the for loop into a nice, beautiful iterate method. And then of course, in this case, we say for each, and we will simply print out system.out, and we will say println and print it. So you can see in this case that both the iterations are performing the same thing right now. So the new iterate method does a fairly good job. On the other hand, what if you had written the for loop in a way you don't provide the bounding condition? You know that the traditional for loops allow us to do this. In this case, of course, if I said if I is greater than 12, let's say greater than or equal to 12, we want to break out of this loop. Well, the top loop right now doesn't have a bound to it. So how in the world can we create the bottom one to do something similar to it? The first step is don't try putting double comma, that won't work. Well, the point really is the iterate method has been overloaded for this purpose. So the iterate method can take 3 arguments, or you can just pass 2 and leave out the predicate. In this case, this becomes unbounded, so be careful. So you want to say take while, and given a value I, you can say I is less than 12, and you can perform the operation. Remember, take while is kind of like break, so we are able to do that pretty nicely here as well. And that is basically the iterate method that you can use in Java 9, so that elevates the functional style to a real nice power, as you can see on your hands. So that's pretty useful, as you can see, to provide that kind of method. So you can see we can use an unbounded version, or we can use a bounded version as well. One last thing I want to quickly mention is about optional. Well, we already have optional, of course, in Java 8, but there were a few things that were missing with optional when it comes to Java 8. Let's quickly understand what those are in this example. Let's say we have a list of numbers one more time, but in this case, I'm going to call a process method. And the process method takes a numbers.stream, let's say .filter, given an element is less than, let's say greater than 5, but then I'm going to say .find first and send the first element. Now we know that an element may not exist to meet this criteria, because if I were to call this one more time, notice if I said greater than 50, we know that in the given input, there is no element that's greater than 50. While we may say the result here is the value of 6, the result here is non-existent, so how do we really deal with it? So to deal with it, what Java suggests is that we use optional. So in this example, I'm taking process, and this is simply to show you how this works. I'm not suggesting you pass optional as a parameter function, so don't take it like that. So in this case, what I'm going to do here is simply pass a result just for this example purpose. So when I get the optional as an input right here, what am I going to do with it? Well, I want to print out the result right here, so we'll print it out. And let's put a little line between those so we can see the difference between these two. Now when I run this code, notice it says optional 6 and optional empty. But how do we get the element out of it? Remember, the purpose of optional is to make sure we don't run into an accidental null pointer exception. Anyone here who loves null pointer exceptions? No, not a single person raised the hand. So I can't. No, okay, he was scratching his head. He's like, no, he's waving at me. No, definitely not. Absolutely. We really don't like it. Well, you don't want to accidentally get into a null pointer exception, so you want to really make sure the code is very predictable when you are using it. Well, that's a great idea, but how do we get the result out of it? Well, you could call a get method, but unfortunately, get is one of the saddest methods in the JDK. Because when you call get, if the value doesn't exist, it will blow up without any notice. So this actually defeats the whole purpose. As you can see here, when I run this code, it blows up. So I have only one recommendation for you. Here's a very nice way to use get. Please, when it comes to get, please forget. That's the best thing to do with get. So I don't recommend using this method at all, but the question is, how do I get the value out of it? Well, one way to do this is to say result.or/else, and you can give a substitute value if it doesn't exist. That's available in Java 8 as well. However, if you really wanted to, you could also do this. You could say if result.is present. Again, all this is Java 8 solution. So this is available in Java 8 also. So is present. Then you can say the value is, and then of course you can say result.or/else, knowing very well you would definitely not be using the 0. Otherwise, you can say output no value. Well, that worked, but unfortunately notice this is an imperative solution. Hey, what if I want to use lambdas as more of a functional style solution? Well, what you could then do is you can say result.if present, and then you can take the element given to you and you can beautifully output the value is plus e, and you can output it right off the bat. Notice how smoothly the value is extracted for you. You say, great Venkat, but what if the value does not exist? In all honesty, they totally forgot the else part. And so they said, oops, we better do this now. So they provided an alternative to this, and that is result.if present, and then of course a beautiful or else added now. So now you can say, if the value is present, you can say output, for example, and we can say the value is, and of course the value being printed, and as we know, the structure of this tells us it's a consumer, because it takes a value, doesn't return anything. But of course, if the value doesn't exist, what are we really going to do? If the value doesn't exist, obviously, you're not going to get a value, so there is no value coming in. Then you can say no value right here. What in the world is that? Well, if the top one is a consumer, this one is of course a runnable. So the if present or else takes two arguments. One is a consumer and the other is the runnable for you to do the work. So this has been added to Java 9 now. So that makes it for a nice functional style to be able to do this. Similarly, they've also added a bunch of other methods as well. One of them notably is the OR method. Very quickly, what OR is going to do is a transformation. Well, if you think about OR else that we saw earlier, the OR else is injecting an integer or whatever the type of the optional really is. We also, so thinking about it, OR else takes a type T. If you look at map method on the other hand, this takes a function which will take an element and then it will transform the element. Well, the result of this is optional. But notice, we have a way to inject a value, we have a way to transform a value, but if a value doesn't exist, what if I want to introduce a new optional into the mix? That's exactly what OR is going to do. OR takes a supplier, but it returns an optional of whatever you want to inject, you can inject into the mix. So this gives a nice way for you to inject an optional if you don't have an optional already. One last thing I want to quickly mention here is to step back to this and let's write a method called iterate for just a second. The iterate method is going to take a stream and it's going to take a stream and iterate through a stream. So in this example, I'm passing a stream to this method. So we'll start with a stream. And given this numbers collection, I'm going to call the iterate right here. So the iterate method takes numbers dot, let's say, stream over here. And once I create a stream from this, I'll call a filter given an element. Let's say element is greater than 9. And then I'm going to just pass it to this method. We'll call this one more time just for our purpose. Let's go ahead and say output. In this case, we will call this as element is greater than 10. Well, as you would expect in this particular example, just for the fun of it, let's call this one more time. And in this case, of course, call it again, but we'll say greater than 8. Well, this particular code is going to call this stream, we'll say dot for each, and system.out println, and we'll just print the value. When I run this code, notice it printed a 9 and 10, printed a 10, but there was nothing to print, so we know what a stream can hold. Well, a stream, if you really think about it, you can think about it as a stream may have a 0, 1 or more elements. So that's basically what a stream contains. Could be an empty stream, could be one element or any number of elements. On the other hand, if I go back to this code and if I say dot find first, well, if I say find first over there, if I also say find first over here as well, and also call find first in the last one also, now what's going to happen? Well, now the find first is going to return an optional, not a stream. Well, we know that a stream is not optional, option is not a stream, so the code doesn't compile at this point. It says optional integer cannot be converted to a stream. But how sad really? Because if you really think about it, you could say optional may have 0 or 1 element. Well, then it kind of appears like an optional is a subset of stream after all, we could argue. Well, if that is the case, if you can iterate over a stream with no values at all, you can iterate over a stream which has only one value, why shouldn't you be able to iterate over an optional which has 0 or 1 values? Well, the answer is nothing should stop you from doing it. So you can convert an optional to a stream using a stream method now. So this becomes very convenient to use an iterator with an optional as well. As you can see in this particular example, you can take the find first and you can call a stream on it, and then you can pass it down. So that's a newly added method as well into the stream. I'll mention quickly a few different additions here in the next couple of minutes. One of the additions to the language which I'm really happy for is a beautiful way to create a list. So we can say list of integer, we'll say, let's call it as numbers is equal to. No more messy new array list, no more messy arrays.as list. Even though it may pretend to create an immutable collection, it's actually mutable. But a list.of actually creates a beautiful immutable collection. When you run this notice, that's a list we created using the off. But if you're curious what kind of object you created, ask for the class information, and you will notice that this class is an immutable collection $list_n. However, for fewer values, it's optimized, as you can see. Notice it's not a list n anymore, it's a list 2 at this point. Similarly, it's a list 1 at this point. And what if I create something empty? Notice it's list 0. No, there's no list -1. The point really is, it becomes a really easy way to create these specialized immutable collections. And since we are really focusing so much on functional style, this is actually a really good idea. So this is a list that we just saw. Similarly, you could also create a set as well. Let's say a set of string. In this case, we will say set, and we will call this as names, and we will print the names right here. And when we print the names, let's go ahead and provide a value here. We'll say Tom and Jerry, and we will say Spike over here. When I run this code, notice you have a Tom, Jerry, and Spike. Well, there's no guarantee of ordering in general. So if I were to go ahead and create a Spike right here, and then Tom and Jerry after that, and run the code, well, okay, there's no guarantee of ordering. Well, just because it orders doesn't mean it actually does it. This is where the demos kind of doesn't really favor me. But the point is, there's no guarantee of ordering. Well, but if I put a Tom again here, you know how troublesome Tom usually is, and when you run the code, it blows up, you cannot have duplicates in the code. So will be the case if you try to add another Jerry as well. But the point really is, that's a set. But here's what I'm really excited about, is a beautiful map of function, .off. So in this case, I'm going to say string comma integer, and we'll call it as a map is equal to map.off. And in this case, I'm going to simply say, the map of says, given a A, I want to have a value 1, given a B, I want to have a value 2, and given a C, I want a value 3. And of course, I can output the map. Isn't that beautiful? Key value pairs. Now, what's really nice about this is, because I've assigned it to a type right here, if I were to make a mistake, suppose I say D comma blah right here, you get a compilation error for incompatible type. But not only that, what if I were to provide this, but I forget to provide a value, what's going to happen? Well, if you don't provide a value, you will get a compile error. What kind of compile error will you get? Well, you're going to really make Java angry. How angry are you going to make? It will not only just tell you you're wrong, it will call you names, as you can see right here. So don't ever try to do that. But the point really is, you get a nice compilation error because these are all overloaded methods, so you get a really rapid feedback when things are not going really well. Well, similarly, you can have look at a few other additions. One of them is the completable future has a few externalized methods. One of them is a copy method, the other is a timeout method. I think the timeout method is absolutely essential. Similarly, if you're interested in walking the call stack, you can use a stack walker to walk the stack. What a tongue twister. And then of course, you could also use JShell, which is the REPL for Java. One of my favorite tools in Java is JShell. I'm a huge fan of REPLs because you can experiment and play with command line tools really nicely in a lot of different languages. So here is JShell, and I'm going to simply type a little experimental code right here, and I can start playing with things right here within JShell. I call this the micro prototyping tool. I'm a really big fan of it. In the next 8 minutes, I want to quickly talk about modules just to give you a feel for what those really are for. So to understand this, let's talk about modules real quick. So to do this, I'm going to take a look at an example of a little code that I want to start with. This code I'm going to start with, we'll start with a little build file and play with it. So here is a little example of a build file. All it is doing some compilations. Don't get too excited about it. All it's doing is simply compiling using Java C and displaying stuff. So no need to really focus too much on this. But let's talk about the problems we are solving. Well, the JDK itself is modularized. What does that really mean? No more one big ball of mud. Well, how many of you here use Swing on a daily basis? Not a single person raised the hand yet. How many of you use Corba? I know it's scary. Not a single person. I got good news for you. If you ever need it, it is there waiting for you. Well, the point is, most of us are not using it. Why carry it with us? Well, that's the purpose of modularization. If you say Java list modules, notice Java is now modularized. Here are the modules in Java now. And if you go deeper and look at it, there's the scary Corba sitting right there, but you're not required to use it now if you don't care about it. Similarly, other things like Swing sitting there as well, and you could use them. Well, modularization is Java has been modularized to break into smaller components. But let's take a look at our own code to think about modules. So I'm going to open up a bunch of Java files here to take a look at it quickly. It's a very short example I'm going to give you. Well, Fibonacci is just a class, nothing special over here. And then, of course, I have a helper, which is an interface, nothing special here. My helper implements helper, but my helper is in an impl package. I don't mean to give it to anyone. So that's all regular Java code. Well, that changes right here, a file called module-info. Here I create a module, and I call this module as, well, we'll give it a name, com.agiledeveloper. And nothing really here except I'm going to export, and in this case I'm going to export the util package. Think of it as a handshake. If for a handshake to happen, I've got to extend my hand and you have to extend your hand as well. If I don't export my packages, you cannot use it. If you don't require my module, you cannot use it. So the handshake has to happen on both ways. So here I exported my module. So far so good. Now let's take a look at what just happened here. If I run the build on this piece of code that we just created, notice that it tells us that our package requires the mandated Java base. Every module requires it. It exports the util. It is not exporting, it just contains the impl itself. It's not releasing it. Well, okay, great so far. Now let's go to another example here and look at this little example of a find user. What does the find user do? I'll come back to this use helper in just a few minutes, so we'll worry about it a little later. But for now, simply notice I call Fibonacci and call a method on it, just a regular class. But what I'm going to do here is to create a module, and in the module, I'm going to simply create over here .first. Within this, I'm going to require the module com.agiledeveloper. You export packages, but you require modules. Now that I've acquired that module, well, without it, I'm going to get a compilation error. But now that I required it, let's go to the build file one more time and take a look at the build itself, how this is going to work. So let's edit the build.sh for a minute. And notice in the build file, all I'm doing is calling the Java and running the program in the first. That's all I'm doing. So go ahead and run the build file, and notice at this point it is giving us an output of calling the fib. So this is because we released or made the package available. If I don't make the package available though, if I did not export the package when I created the module, notice that I get a compilation error saying that I'm trying to use something that's not being provided. I obviously cannot use it. Similarly, I cannot use what I did not require as well. Notice at this point, without the requires, but with the exports, my code doesn't compile also. So that's basically what's going on here. Well, all that is great, but the question is, what about things you didn't make available? Well, at this point, notice I'm calling the use helper. When I call the use helper, I go here and just print out the helper right now. We'll take a look at the rest of the code in just a minute. So all I'm doing is just printing out the helper. Now when I run this code, notice this is telling us that the helper is actually a my helper. It is just an output of the to string. You say, aha, that's great. Now what I want to do here is in this code, I am going to go ahead and reference the my helper physically in the code. Well, I'm going to get a slap on my wrist because, remember, I never exported the my helper. Well, as a result, when I try to compile this code, I get a compilation error saying I cannot do this. You say, all right, fine, compiler, you will not allow me to do it, but I'm a cool Java developer. I've got reflection on my hand. And then you throw a villain smile at that point. And then you say, aha, I can use reflection, right? So notice what I'm doing here. I go to the helper, get the class, get the method called the hidden, which is only available in the helper, my helper, not available in the interface. Now I print it out. At this point, you are like, isn't that cool? I'm getting behind the scenes. Notice I was able to print out the details about the hidden method. And now, with a much more villainous smile, you say, at this point, Java is just watching your move. And now you are saying, aha, now that I came this close, you are going to call the method through the reflection interface. My suggestion is, please don't ever do this at home, especially if you are alone. I cannot guarantee your security anymore. Because when you do this, you're going to make Java angry. How angry? If you don't believe me, see what just happened. It is not just angry, it's very angry. How angry? It says, error. That's how angry it really is. So don't ever do this, as you can see. Thank you, that's all I have. Thank you for coming.